Hey everybody, Mr. Bress here. I just wanted to record another quick video to go over some of the monohybrid crosses in the complete dominance, the sort of standard, the first version that we used or that we learned about. And I think maybe it was we were very simple to begin with, and then the problems start getting a little more complex. So I just want to kind of help you work through just a couple of those in a really quick video. So I'm going to share my screen here, and I'm going to operate out of Canvas. I'm going to head over to Canvas, and let's get to our class, Breast Biology Semester 2, in the modules. And let's go to the yesterday, the more monohybrid cross practice. So if we go here, you can see that I gave an answer key to problems 2, and I even created a little recap video where I go over some of that material. But here, let's try practice problems number 3. I think a few of these are kind of similar to what's going to be on the test. So I'm going to send this out to Notability really quick. I'm going to create a new note, import it. Yup, let's do that. And then let's head over to Notability and let's take a look. Okay, so here we have, let's get right to it. I'm going to do the first 2 problems here in this video. A tall plant is dominant to a short plant. So it gives me some information here that's pretty helpful, but right off the bat, I'm gonna say is tall and little t is short. I just wanna make sure I have that. I wanna get that information dialed because that makes the rest of the problem so much easier. If all offspring of a cross are heterozygous, what were the genotypes of the parents? So here we have, let's pretend these are letters. We crossed 2 unknowns, right? We have no idea what these parents are, but we do know that in our Punnet Square, all of them were heterozygous. So you might think, oh gosh, how would I do this? Well, I know that if I crossed, let's say if I crossed 2 homozygous dominant, all of the boxes are going to be, there's no other gamete here. These are all big T. So all of the offspring are going to be homozygous dominant. So I know that's not right. Well, what about homozygous recessive? Same thing there. All of these, right? Because this would be little t, little t, little t, little t. All of those are going to be homozygous recessive. That's not going to work either. So a little bit of this is trial and error. Okay, let's do something that's a little closer. What if I know that there's going to need to be somewhere in here, I'm going to have one of the parents is going to have a capital T, and the other one is going to have lowercase t. So what if we did something like big T crossed with heterozygous? Well, I know right off the bat in here, I'm already getting 2 offspring that are homozygous dominant. And this says that all the offspring are heterozygous. And we're trying to guess the genotypes. Again, this is kind of a bad question because you could have a scenario where this happens and just out of chance you get all of those. I'll make sure that there's no questions like that on the test. What I think this question, and I borrowed this from another resource, what I think this question was really trying to get at was that the best option is a homozygous dominant crossed with a homozygous recessive. And in that case, you would get this, and in which case you have a 100% chance of getting heterozygotes. So this is, I don't love this. I would have said that what is 100% likelihood. Okay. So let's see if this next question is a little bit better. So a round seed plant is dominant to wrinkled. So right off the bat, let's write capital R is round and lowercase r is wrinkled. Okay. What parental genotypes will produce offspring that are 50% homozygous and 50% heterozygous? So again, we don't know what this cross is, but we know that we're going to get 50% homozygous dominant. That's 2 out of 4. And we're going to get 2 out of 4, and 50% are heterozygous, and 50% are heterozygous. Okay, so our Punnet Square box is going to look something like something like this. How do we get this distribution? Well, we know from above that something like this is going to get us all hets. So that's not going to work, right? All hets is not going to work. So, or homozygous dominant, homozygous recessive, that's not going to work. I think we know right off the bat that homozygous, come on, that's not going to work, right? That's not, there's no way from that. There's no little r in there. We can't get heterozygous. Likewise, we know that little r cross, 2 wrinkled cross together. There's no big R here. There's no way we could get that or that. Come on, that's not going to work. Another one we could try would be, what about 2 heterozygous crossed together? Might that produce it? It seems like it could get a little closer, but you know that the 2 hets crossed together has this classic pattern where you get 25% homozygous dominant, 25% homozygous recessive, and you do get that 50% heterozygous, but it is not what we're looking for here. So we've gone through every other iteration, and I guess there's only, well, there's 2 left. One left would be, what if we did heterozygous crossed with homozygous recessive? And here we would have, oh, but I already see a problem when I do that down here. I'm getting 2 wrinkled plants. That's not going to work. So we are left with only one other option. Homozygous dominant crossed with heterozygote. When we do that, we get big R, little r. And here on the left side, we get our homozygous dominant. And here on the right side, we get our 2 out of 4 heterozygotes and 2 out of 4. So the parental genotypes have to be that right there. And actually, it looks like I might have time to do one more in here. Let's try problem 3. Oh, and this one must be referring to the top here. And in the test will be a lot more clear. A homozygous round seed plant is crossed with a homozygous wrinkled plant. And so above, what we would have said is big R is round, little r is wrinkled. And so if what percentage of the offspring will be homozygous? So we cross a homozygous round seed plant, so that's 2 R's, crossed with a homozygous wrinkled seed. And the question is, what percent of the offspring will be homozygous? Well, I already know that it's going to be 0% of them because these come over here, big R, big R. These come here, little r, little r. And there we go. These all are heterozygous. 4 out of 4 equal hetero. That's a big R and a little r is hetero. So this is 0%. Okay, that was pretty quick. Let's try another one. In pea plants, purple flowers are dominant to white. Okay, so I'm going to put capital F equals purple and lowercase f equals white. See how I do that right off the bat? I try to get this information down. What parental genotypes would produce offspring that are all heterozygous for the purple plant? Well, we know that our best version of that, here, I'm going to pause for a second. You can pause the video here and try to figure that out. And now I will give the solution is if you have a homozygous dominant crossed with a homozygous recessive, you get, but these are here. This is the scenario in which you get 100% heterozygous. This is 4 out of 4 equals hetero. Okay, so this seems to be a takeoff of this one here. Let's try B here. If out of 100 offspring, 74 are purple and 25% are white, what are the probable genotypes and phenotypes of the parents? Well, that is approximately 3 out of 4 are purple and approximately 1 out of 4 are white. And remember that the dominant gene is purple and the recessive gene is white. And this 3/4 to 1/4 reminds me of, I'm just going to erase this here, reminds me of 2 heterozygotes crossed together. And you can try all the other combinations and you'll see that they wouldn't really give you that. They're not the most likely ones to give you this combination. So this goes here, capital F, little f, this one here, capital F, little f, and we get 1/4, 1 out of 4 is homozygous dominant, 1 out of 4 is homozygous recessive, and then 2 out of the 4 are heterozygous. But what we see then from here is 1 out of 4, 25% are white. And 3 out of 4, 75% are purple. And this 3 out of 4, 75% reminds me of this 74 out of 100 are purple, and 26, about 25%. Remember, this is just a probability. We're trying to see what makes the most sense. And so things aren't going to be exact in the real world, but we would guess that the parents are heterozygote. And if they're heterozygotes, they are purple. And finally, in this question, same thing, F equals, let's just make this here, purple, little f equals white. What are the parental genotypes needed to produce 100% white flowers? So think about that. Okay, well, anytime, even if, so let's do the craziest scenario. So if you did a heterozygote crossed with a homozygous recessive, in this case, you're still going to get, this is not going to get you 100% white flowers, because look, this top row here is getting that homozygous dominant gene. That is not going to get you 100% white flowers. The only way you can get 100% white flowers is if you cross 2 homozygous recessives together, so that it's little f, little f, little f, little f. And in this case, you will get all homozygous recessive. 4 out of 4 equals 100%. Little f equals white. So, all right, well, I hope that the more we practice this, the more we're getting a little bit more comfortable with moving these kind of around and picturing what could happen in the future. And some of it is just trial and error. And the more you practice, the better you're going to get at this. So happy practicing. Again, email me with any questions, and stick around for the office hours where we go over some of these problems. So see you next time.